Welcome to Study Loop.
Okay, so we are going to start by simply reversing our delta H value. And in part A, the question says, what's the enthalpy of the reverse reaction? Since the original delta H of the forward reaction is never negative 726 kilojoules per mole, the reverse of that would be positive 726 kilojoules. Secondly, if we're going to balance the equation with coefficients, here's your methanol, and then here's your oxygen. Now you notice they've already put coefficients in front of it, but it's not balanced yet because they haven't gotten rid of the fraction. And so the fraction needs to be removed in order for that to be the case. So all we're going to do is multiply all of our coefficients by a number that's going to get rid of that fraction, in this case 2. So by multiplying everything by 2, we'll end up having coefficients of 2, 3, 2, and 4. Thirdly, it says which way is more likely to be thermodynamically favored, the forward reaction or the reverse reaction. Now, all favorability of reactions is based on having the smallest amount of energy possible. All reactions want energy to be reduced. So we're going to say that the favorable reaction is going to be the forward reaction because the negative 726 is losing 726 kilojoules of energy, and that's very favorable. Last part of the question here says, what happens if this said gas instead of liquid for the water? What would happen to the magnitude of the delta H value? If we're just talking absolute value of it, we're going to say that it's going to go down. And the reason for that is some of the energy is going to be used to turn the liquid water into gaseous water. And that takes about negative 286 kilojoules per mole. So if you took the negative 726 and subtracted 286 from it, that would give you a rough estimate of how much energy that would require. Hope this helps.